Hello everyone, I'm here with a more advanced tutorial today. I'm going to be going over how I grade curbs. It's a little unconventional. Basically, this is inspired off another YouTube video. Someone gave a presentation, I believe it was in an Autodesk conference, on how to use a draped surface. The concept being you have a design surface that's flat, and then you have a bunch of curb feature lines, and they inherit their elevations from this design surface. The back of curb is 0.5 higher than the design surface, so you can see how it just kind of, you're effectively draping a curb over. And that kind of got me thinking, is there a way to kind of make that more automatic? And that's exactly what I have. There's a couple different ways to grade curbs, and none of them are great in my opinion. So this is the first one, which is just use your kind of curb line as your design line. The trouble with that is often you end up with these weird scenarios where I want to grade 1% from a straight line here to here. I don't want to grade 1% on this curve and then 1% up. It's just, yeah, these small radii just throw a wrench in everything. Even the big one too. Like I want to grade from my curb line till I hit this existing drive here. This is an existing road, let's say, and then this is my, finished grade. So you often end up with scenarios where your curb line geometry just kind of throws a wrench in what you're actually trying to do and just makes everything more convoluted. So you usually end up with something like this, where I have a kind of design line here, and then you might make a curb on top of that and have it inherit. Overlapping feature lines is not awesome. It does cause some instability, or you have, and then from that you can either do a stepped offset, or you can use grading features. That's the other thing. Grading features kind of stink. They're super buggy. If you've never noticed, stop using them for a grading plane or two, if you can, and you'll notice it crashes a lot less. So I don't use grading features either. So with those constraints, this is kind of how I arrived at where I'm at. Basically, I have two surfaces in here. I don't know why I said that. That's a total lie. I have way more than that. So there's a drainage design surface, which is flat. It's basically pretending that the curb does not exist. And how do I do that? Because you're like, well, how do you just ignore something like that? Basically, I've graded this area, this drive, 0.5 higher than it will be in the end. So you see I go from landscape here, and I maybe go, I don't know, 1.5% to this what looks like a curb line here, but I don't go down 6 inches. I just leave it up. I leave it up the whole way, and then I have a subtraction area, and that's this area right here. This area gets dynamically lowered 6 inches. You can kind of see where this is going. So I have this surface, which I've been modeling, and I have my nice break lines how I want them. They don't have to follow these little radii here. You can see this is just my break lines here. There's no feature line on this curb. And then with this subtraction surface, I subtract 6 inches there, and then I end up with an FG that looks like, you saw it earlier, this. So you see here, it's subtracting that 0.5. Looks super clean. And it's super easy to modify your curb geometry if something changes. I'm gonna rebuild automatic that. And you see, without even changing any feature lines, my curb line there is now updated. So you can see the time savings are obvious. I'm not even going to go over every benefit that this gives you, but it allows you to, one, get your curbs added in your preliminary designs faster. It's one thing you always want to kind of kick down the road just because it's such a pain to do otherwise. It allows you to get it in there super fast, but more than that, it allows you to continue rolling with the changes without having to worry so much about just updating your curbs or making sure they're updated. One, it's super easy to change curb geometry, like you saw. Like, let's say you added an island and you don't actually need to update the overall design here. Like, this feature line kind of still works. It all drains down 1% this way. I'm just adding a like little island here. Perfect. Just update your curb polylines. Or let's say I wanted to like change kind of some of the drainage patterns, and then I just don't have to worry about my back of curb lines anymore. It just figures itself out. See, we made that really flat now. So benefits are obvious. How does it work? How do we set it up? Oh, this is an unrelated note, but I already tried recording this, but the Windows snipping tool defaulted to no microphone input, and it does that every time you start a new recording. And I've lost 30 minutes of footage with no microphone. So thanks, guys. All right. So the first thing to do is your tie-in points. Anytime I'm tying into drive level stuff, anytime I'm connecting at drive level, I need to make sure I'm raising my connection, my existing feature line 0.5, so that way when we subtract it, it matches up. The idea kind of is here, we have our back of curb tie in here, which is normal. We're just tying into this kind of landscape with this landscape at this back of curb here, and then we have our drive connection here, where this is an existing road curb here. We're ripping that up because we're connecting with the drive here, so we're actually tying into pavement level here, and then once it finishes, we go back to tying into the kind of existing curb that's there. It's pretty standard stuff. I'm going to take this line, this is where we're tying into pavement level, and I'm going to raise it 0.5. Not because the existing curb is 0.5 exactly, it may be less than that, but because our curb is 0.5 feet tall, if that makes any sense. You can see in Project Explorer, we can compare it to our EG, and we are exactly 0.5 higher than it. That's what we want there. We're going to do that for this one as well. So just make sure to do this when you start grading, and then you can just ignore the curb. You can draw feature lines across your curbs all day long. Like if I wanted to go from this to the building here and just quickly create a feature line here. I don't know why I clicked that, because I don't want it to inherit from elevation. This is also the completely stock Civil 3D template, so that's why it looks the way it does. And it might be misleading because you're like, well, don't you need to like worry about like going down 6 inches here? This isn't the actual slope. This is going to get steeper, right? It's not. If you think about it, well, just think about it. This is the actual like slope of the sidewalk up here, because we're just subtracting 6 inches down here. This slope isn't going to change. So it makes it super easy to just cross your curbs all day long. You don't have to worry about it. It saves you a ton of time designing when you don't actually have to worry about like making sure every single time you cross the curb has a little elevation point there. It simplifies a lot of stuff. And then once you're ready to add your curb, because you're just kind of a flat surface, it doesn't really make sense. Then we'll get that going. So you just make sure your tie-ins are good, and then you start grading and ignore the curb, and then once you're ready to add the curb, we're going to do this stuff. So first of all your brake lines are going to go on this. This is not your FG. This is going to be that drainage design thing we talked about. So I'm going to rename this because this is a better name. It's not going to be our final FG that we're going to annotate and use in other drawings. I'm going to rebuild this because I think I changed some grades there. Let's go up like 2% there or something. I don't know. Sure. Rebuild that. Perfect. All right. So it's flat. Pretty much. It doesn't have any curves in it. Now we're going to create our subtraction surface. So first we need to copy, if this is your grading file, you probably won't have your base curb lines in there. So you just copy them in real quick. We need a closed shape. Technically we don't need one, but it makes things a lot simpler and reduces risk of errors. So I'm just going to close this guy by basically it literally does not matter. You can just click here and then here and here, and it's totally fine. Although, gosh darn it, those are lines, so they have elevation and they're going to join and create not a polyline. I'm going to turn on no snap Z here, and I'm going to be using polyline from here on out. Yeah, this detail is not going to kill you. I'm going to join that up. Perfect. I'm going to join it up here so we get one big line going. I use the regular line command again. On my actual workstation, I have that mapped to polyline, but this is a new install and I haven't set anything up yet. So I'm going to delete the back of curb line because I'm just going to re-offset it so we have two close shapes. I'm going to offset it 6 inches. There we go. And get the right layer. This is obviously a line you wouldn't want printing, so you could put this on a no plot layer. I keep all my grading model in a separate drawing anyways, so I keep annotation and like plan production separate than the actual drawing with all my feature lines and stuff. Okay, these feature lines need to be the amount we want to subtract our surface from. So this guy right here is the pavement level, so we want to subtract 6 inches, so it's 0.5. And then this guy is not pavement level, so it's landscape. So we just want to leave it alone. And remember, all these other break lines where we're tying in landscape or top of curb level, we just assign them to our EG like normal. We're not doing any subtraction funny business. This matches our EG exactly. The only time you're adding 0.5 is at pavement level tie-ins. So see where it's 0. And the other thing was we need a bigger boundary. We need to make sure this encompasses our whole site. And this is just going to be to make sure that the boundary of our little subtraction surface goes well beyond our FG there. That's important. I'm going to put this on a layer. See topo feature line hide. We don't really need to see it. So once we're done with it, we can freeze that layer. And we're going to create a new surface here. This is going to be our subtraction surface. I'll call it curb height. It's not really the curb height. It's kind of the inverse of that, I guess. We'll leave it on contours and triangles just so we can see it. And then we're going to turn it off when we're done with it. I never want this surface to be out of date, so I'm going to make sure it's rebuild automatic. We're going to add our outer one to it as a break line. This is a polyline. A lot of people don't know you can just add polylines as break lines. We need supplementing factors on. 100 feet is fine. If we don't turn that on, it's going to have some missing triangles because this polyline is so big and there's only 4 corners to it. I'll call this outer. All right, so we got a flat surface. Awesome. Now we're going to add our curb lines to it. I'm just going to select those. You can use select somewhere. And then right click here, add break lines. Standard is good. We don't need supplementing factors now because these curb lines have way more points and they're in the interior of the surface anyways, so we're not worried about missing triangles. If we add supplementing factors, it'll add unnecessary triangles and just create a bigger surface. I'm using a mid-ordinate distance of 0.1 there. All right, so now we have a surface that kind of looks like an inverted curb. Imagine that this is going to stamp into our drainage design surface and leave like these areas like are going to be depressed essentially. So kind of, yeah, imagine this is a big stamp that's just stamping into our drainage design surface and lower. There's areas 6 inches. It's exactly what it's doing. So how do we get it to lower 6 inches? Well, we use a volume surface, which is a little bit of trickery because volume surface is actually just subtracting 2 surfaces between each other. So the base surface is actually the minus operand. So it's the one that's this is the value that we're going to be subtracting by. So we're going to use our curb height. And then the comparison surface is actually the one that's getting subtracted from. I don't know how to phrase that in English. We're going to use our drainage design for that. Make sure these are 0.1. And again, I'm going to turn these on contours and triangles so we can see it. I'm going to turn this outer one off because I forgot to do that. And I'm going to freeze this layer, the feature line hide layer, because I don't need to see that. It's not a feature line actually, but You see now we got all those triangles, and you can see it's kind of creating triangles at the intersection of those two. I'm using surface smoothing, which is why I have so many triangles here. I'm just going to put this on regular contours here. And you can see now we have the surface we started with, the drainage design, which just cuts through curbs, and then we have this new curved one, which anytime it goes through a curb, it's lowered 0.5. We can look at that here, and you can see here it's doing exactly what we want. And this is totally dynamic. We're going to make sure this is set to rebuild automatic. I forgot to name this. I'll call this curved. And I don't think I touched on this. Anytime this curved line travels outside of the boundary of our surface, it is nonsensical. So don't get caught up with, well, why does my curb keep going? I mean, it's in the middle of the road. That doesn't make any sense. It doesn't have to. It's outside the boundary of the surface. So what this line is doing does not matter. It's just the reason we're closing it is just to keep everything more organized and make sure we don't have any weird transition areas where it's not doing what it's supposed to. So yeah, make sure you close it like this, and don't worry about the fact that it's not what your actual curb line is doing. Of course it's not. It's totally fine. Anyways, back to this surface. I noticed I didn't call this FG. Sometimes you want additional edits to do on this. Exactly what edits I won't talk about, because you want to make sure all your break lines and surface smoothing, whatnot, goes on your drainage design. So you're like, well, what would you put on this? That's besides the point. But if you do have any additional edits, notice you can't really do any edits to a volume surface. You can data shortcut it and, annotate it and whatnot, but sometimes you want to do additional stuff to it. You see, this is all the normal edits we can do. So you need to get it back into a tin surface, and we're just going to do that by creating a little proxy surface here. We'll call this one FG. I'll put this on 1.1 and 5. You'll notice it's totally empty. I'm going to hide. We have so many surfaces showing here. FG. Okay, I'm just going to turn off my curved one. I can actually scroll over that to get to no display, which is kind of cool. Our FG is empty right now. Obviously doesn't have anything, so we're just going to paste our curved onto it. And notice now we have all these edits. This is essentially just a proxy surface. Anytime the curved updates, this FG updates. I'm going to set this to rebuild automatic. I never want it out of date. Same for the curb height, curbed, and FG. The only thing I'm going to leave not rebuild automatic is drainage design, because I'll know when I'm changing feature lines, I'll just rebuild it. And I don't want it rebuilding automatically because surface smoothing takes some time to process. So I'm just going to leave it like that. And now if I needed to make any edits to my FG, I can do that after this little subtraction thing happens. Any edits that you need to do before that happens, you obviously just do to drainage design. And now you see we have this nice editable curb line here. If for some reason it changes, I'm going to shift select these vertices. It just updates. That's the wrong one. There we go. See, it just updated that area we did, which is crazy how that just works. And then if I change the slope of this kind of area, it'll just update everything there. It'll update all the curb without any grading features, without me having to redo a stepped offset. It's beautiful. One thing I noticed people commenting was that, say you have an area like this where you're going at 2% exactly. Let's say it's a accessible sidewalk, so you have that max 2% slope. It's actually, 2.08, but we're just going to pretend it's 2%. And you go 2%, and you notice, well, it's actually continuing to slope from the curb. Normally, this would be exactly 6 inches lower, but because we have this feature line with a 2% slope through it, 6 inches lower and 2%. So it's a little bit over 6 inches lower. But we normally put spot grades on the plans at the at this elevation right here, and we just, they have a note saying the curb is 6 inches tall. So 6 inches tall from here to here actually puts us at slightly above 2%. So that you do need to kind of keep that in mind. You don't want to go exactly 2% anyways, but just note that there are a little bit of slope through the curb, so it's not 0.5 high exactly. That's totally fine. You just need to make sure in a pinch point like this that you're aware of that and you don't go exactly 2%. You leave yourself a little bit of tolerance, which you should be doing anyways. The other scenarios, like let's say I had a parking stall here, which I do, and I wanted to go 4 to 1 immediately after. So you'll draw a little polyline here and then go, a little future line, and then go to your tie-in or whatever. And I start going 4 to 1 immediately. Just note that you can't do that either. You need to either add an elevation point right here, right there, and keep this 0, because otherwise you're sloping 4 to 1 through the curb, which is actually 0.12 feet, which obviously is not fair. You can't slope through the curb. So just in areas where it's really tight like that, keep in mind you either need to add an elevation point there and keep this 0 and just let the curb thing do its thing, or move this feature line here and actually just move it back to your back of curb line and then grade 1% up to that back of curb, and that'll kind of handle it there. So just in pinch points, just be mindful of you are kind of shortchanging the curb a little bit. It's not 0.5 high exactly, but it's close enough, and it just does not. I've used this successfully on many projects. It's as long as you know what you're doing and you realize the shortcomings of the simplification, you're totally fine. The other place this gets convoluted is variable height curbs, or areas where we briefly go no curb. Like let's say we had just along here, just along this line right here, we had no curb. You can really confuse yourself. Ask me how I know that. Basically, the thing to remember is that this line right here is not your curb line. It is a subtraction line. This line just means that anything inside this area, we're subtracting 6 inches. So think about what I want the end result to look like. If I wanted no curb here, then that means that I need a transition area. So I need a transition to where my curb gets no curb. So let's say I pick right here to there. That's going to be a little 10-foot transition. So it's going to be full height here and then go to 0. So there, perfect. And then same over here. That's what I want to happen. And then it's going to be no curb here. So that's what I want to happen. So now I've got a kind of mental image of what I want in my head. And now I ask myself, how do I get there knowing that everything inside here is going to be subtracted 0.5? And then everything on the other side of it is going to be, subtracted nothing. And then with that kind of guiding you, oops, almost lost my mic there. Then you realize basically here, along this line, I just need 2 future lines. Uh-oh. There we go. I need 2 future lines, one for my face, one for my back of curb, and essentially I'm going to do a reverse curb here, where this line right here is 0.5 lower than this one, to even out what I know the surface is going to, because it's going to subtract 0.5 from this one. And if this one's 0.5 lower, then they actually end up being, they end up matching up. So what this does, it's a little convoluted. I acknowledge that. But if you think about it, we're now only modeling the exceptions instead of the norm. So the norm is that you have a 6-inch curb everywhere. Instead of modeling that everywhere we have a 6-inch curb, it makes more sense to only model the areas where we don't have a 6-inch curb. So make the easy part having a 6-inch curb, and then only worry about the scenarios where you don't have it. So it kind of shifts, it kind of inverts it. So yes, this is a little convoluted, but it's way better than having to model all these curbs manually. And the other thing would be curb ramps. That's a little tricky. I'll do another video on that. It's very elegant how I do it, but it's just a little tricky, and it took me a while to come up with it. So I'll do another video on that. But that's all for this one. If you guys have any comments about how I deal with certain situations with this, I've been doing it this way for a long time. I really like it. It saves me a ton of time. So just wanted to get that out there for anyone else. If anyone else has If anyone has any questions, let me know, and I'll try and respond to them. Thanks. Bye-bye.